This is Woodworth. I'm with the Orbiter program. I'm the chief engineer for Orbiter Element. I'm here to talk about testing, and testing is a necessity as far as any design of vehicles in order to perform your certification or your qualification, even standard checkouts or even checking out workmanship. The thing about testing is there's costs associated with it. The more extravagant the tests, the more it costs. So you want to scale your testing to fit the intended purpose. And the basic guideline is to do the right test. If you're going to do qualification testing, you're looking to qualify a design. So there's a lot more stringent sort of things that you're going to put in there as far as your environment, your vibration, your thermal aspects, which would be different than if you're going to go off and do an acceptance test where you're looking to check out for workmanship issues. In other words, you had a box that you went sent down, you had a refurbishment, you essentially changed out a card. You're looking to do a vibration test just to see if anything was left loose in the box. So it's entirely different sort of testing. There's a difference in cost. And then you'd have a checkout testing, which is essentially something you do on the vehicle itself. You're just making sure that a door operates properly or a system that's pressurized actually comes up. For example, like an LRU, which are a line replaceable unit. It's a black box. You have a black box in the vehicle, doing your troubleshooting, you have an issue with it, you have to pull the box out, you have to send it down for refurbishment, the box gets opened up, you end up finding a card that's discrepant, you're going to change out the card. When it's time to button it all back up, you got to go off and run a test. You want to make sure the box functions properly. You also want to go off and do, like I said earlier, a vibration test just to make sure there aren't any loose parts in there. You're not going to go back and do a full-blown design qualification test. You're not going to test it to extreme temperatures, extreme limits. The design's already been certified. The box has already been flown. It's already been used. It's a qualified design. All you're trying to do is find out if there's any workmanship issues and make sure the box functions properly. Another thing we do is checkouts. We got the main landing gear door, for example. You want to do a series to make sure that the door cycles properly within its time constraints or time limitations. You can go through and do a whole series of door cycles in the period of a flow because you're trying to set up for different work operations that may be taking place. The intended purpose here is to do one series of cycles. So you have to go look and see what your original certification plan was. In other words, if you say, in our case here, we had an orbiter that's certified for 100 missions, so you're going to do 100 door cycles as we land. But then on the ground, you're going to be doing a series of cycles to do your checkouts, and then you may do a series of cycles for operation purposes. And all of a sudden, you had a vehicle that's certified for 100 missions. If you certified the door for only 100 missions, you've used up all that on the ground. Another thing is very simple is like a light bulb check. You want to make sure that your lights work, so you go turn on the lights. Well, how many times do you need to turn on the lights before you've actually burned up the life of your light bulb, as opposed to just getting the information you want as far as the checkout? This is Woody Woodworth. I'm with the Orbiter program. I'm the chief engineer for Orbiter Element. The basic guideline is to do the right test and then do the test right. So you've got to look at how many cycles you certified for and make sure you stay within that. If it's the case you've certified it for several thousand cycles, then you may be able to use up some cycles there. But at the same time, you're using up life, so that's a consideration. Another thing is to test the configuration in which you're actually going to use. And a good example here would be like flex hoses. And you can set up a configuration, you can have your flex hoses installed, go ahead and do a full-blown vibration thermal testing on and so forth, and everything may check out well. But what's the difference between an unpressurized and a pressurized flex hose? You're going to get different results. So you need to make sure it's fully documented, but it meets the configuration in which it's actually going to be used or flown. You can go off and do a qualification test. And you're thinking the qualification test is just to go check this box, for example, and making sure it meets the rigors for certification and for flight. But downstream, somebody's going to come back and look at it, and they may want to go ahead and extrapolate that information that you did in your testing. For example, the way the box is installed. The original intended qual test may not have considered that, but downstream somebody may want to look at, hey, the box was installed, we're going to need to go off and do a checkout. Make sure it's installed with the proper hardware that you can actually install it in your vehicle. Make sure it's installed on the same sort of plate that's going to be installed on the vehicle. In other words, if you end up with something that's much thicker or different size fasteners, it's hard to extrapolate that in the future. But if you do end up in a situation where you have to do that, make sure you document it properly so somebody's not trying to second guess later on. Whenever you go off and do any sort of testing, you have to have specific goals you're looking for. You got to understand your intended purpose, state the intended purpose right up front, and then go ahead and completely document that. So you got to scale your test to fit the intended purpose.